Okay, so we're all surrounded by things made out of wood, right? But have you ever stopped to think about all the industrial waste that comes from making paper and cardboard? Well, it turns out hidden inside all that waste is a potential superpower, one that could totally change how we build our world. Think about it. From the chair you might be sitting in right now to the actual frame of your house, what's the invisible force holding it all together? Well, the answer is almost always glue. But we're not talking about your everyday school glue. This is some seriously strong industrial-grade stuff.
And here's the thing. These super strong adhesives, called phenolic resins, are absolutely essential. But, and it's a big but, they're made from phenol, a chemical that usually comes from finite fossil resources. And that, you can imagine, creates a huge environmental question mark for product we depend on so much.
So you see the problem, right? We're kind of stuck. We desperately need these powerful glues, but their link to fossil fuels is a growing concern. For decades, scientists have been on the hunt for a greener, more sustainable alternative that, crucially, doesn't sacrifice any performance.
And this is where our unlikely hero comes in, lignin. Yep, that paper waste we talked about is back in the picture. For a long time, scientists have eyed lignin as a potential replacement for phenol, but it's always had this one major flaw.
So what is lignin anyway? Well, you can think of it as the natural glue that gives wood its strength and stiffness. And it is everywhere, seriously. After cellulose, it's the most common organic polymer on the entire planet. And when paper mills separate wood fibers to make paper, lignin is what's left over. And there's a lot of it.
Just how much are we talking about? Try around 70 million tons of lignin produced by the paper industry every single year. It's a truly massive, renewable resource that's literally right there for the taking.
But here's the crazy part, the huge missed opportunity. Despite all this lignin being available, a whopping 98% of it is just burned for energy right there at the paper mills. Only a tiny fraction, about 2%, actually gets used in commercial products. So what gives?
And this is the catch I mentioned. In its raw, natural form, lignin just isn't reactive enough. It's made of these big, complex, tangled molecules that just don't like to bond in the way you need them to for a high-performance adhesive. For years, this was the brick wall researchers kept running into.
But what if? What if, instead of trying to use lignin as it is, you could break it down first? That's the beautiful idea at the heart of a breakthrough process that finally managed to unlock lignin's hidden strength.
The concept is actually really elegant. Scientists basically decided to use chemistry as a pair of molecular scissors. The idea was to just snip lignin's huge, complicated polymers into smaller, much more reactive pieces. The technical term for it is depolymerization.
The specific method is called Base-Catalysed depolymerization, or BCD for short. To put it simply, researchers take the raw lignin, dissolve it, and then hit it with some pretty intense heat and pressure. This is what cracks those big, clunky molecules into much smaller and much more useful building blocks.
And what comes out the other end is really cool. The process doesn't just create one new substance. It neatly separates the broken-down lignin into two totally valuable forms, a liquid oil and a powder, and each one has its own unique molecular properties.
So now we've got these two new ingredients, a liquid oil and a powder. The million-dollar question was, could either of these be used to create a bio-based glue that was strong enough to go head-to-head with the fossil fuel champion? And this is where it gets really exciting. The researchers took their two new lignin-based ingredients and whipped up a whole series of adhesives, replacing up to 70% of the traditional phenols. Then, it was time for the ultimate showdown. They pitted them directly against the pure fossil fuel-based adhesive.
All right, let's look at the data. These graphs show how quickly the different glues build up their strength. See that solid black line? That's the industry standard, the one to beat. The chart on the left is testing the glue made with the new lignin powder, and the right is testing the oil. Now I want you to focus on that chart on the left.
I mean, the results are just incredible. Look at how the dotted and dashed lines, the ones for the new lignin glue, are sitting right on top of that solid black line. This means the bio-based glue develops strength just as quickly and reaches the exact same peak strength, even when it's made with 70% lignin. It's not just a decent substitute, it's a true equal.
Now, if those graphs were a little busy, this chart makes the final results crystal clear. The industry standard hits a strength of about 14. You can see that glues made with regular untreated lignin fall short. But then, look at the new adhesive made with the lignin powder. At 70% lignin content, it actually surpasses the fossil fuel standard. It's not just as good, it's slightly stronger.
And hey, don't just take my word for it. The researchers themselves said it perfectly in their conclusion. They state very plainly that these modified lignin bits can replace up to 70% of the phenols without harming the final strength, whether it's dry or wet. In the world of material science, that is a monumental claim.
So what's the big picture here? What does this all mean? Well, this isn't just some clever experiment that's going to stay in a lab. It really points toward a genuinely sustainable future for one of our most important industrial materials.
So, let's recap the big wins. First, we can now create top-tier, high-performance adhesives from what we used to think of as just waste. This could dramatically cut our need for fossil fuels in this whole sector. It also unlocks incredible value from that 98% of lignin that was just going up in smoke. And to top it all off, the research showed the new adhesive worked just as well, if not better, in both wet and dry conditions.
A breakthrough like this really forces us to ask a much bigger question. If we can find this kind of high-tech potential locked away in something as common as paper waste, what other amazing, sustainable superpowers are just sitting out there waiting to be discovered in all the other biomaterials around us?